Right, hello everybody, welcome back. Good morning, good afternoon or good evening. In this video I want to show you how to do a t-test in Excel. The t-test is a statistical test that you're more than likely to use at some point in your IA. And basically it's a way to look at one data set or one set of values and compare it to another data set and see if the means of those data sets are significantly different. If you've designed your IA methodology well, then the difference between those data sets will be whatever you've set as your independent variable. So therefore, it's a way to see if your independent variable has a statistical difference or a statistically significant difference between one data set, let's call it data set A, compared to data set B. Right, so a few things about a t-test. Generally, it's used for samples of less than 30 in each of your two data sets, and it assumes a normal distribution around each mean. So therefore, it's the assumption that the variance to one side of your mean is pretty much equal to the variance on the other side of the mean. And that's a safe assumption in environmental sampling. It can be applied whether you're getting your data experimentally or whether you're getting your data from a secondary source. But as I've already said, it's generally used for data samples of equal to or less than about 30 data points. In my experience of marking IAs, that's normally within the range of what you'd expect to collect in your IA. What else can I say about a t-test? It was invented or discovered by a guy called William Gossett. And interestingly, it was in the 1920s and he was working as the head brewer for Guinness Brewery in Dublin. And Guinness didn't like their employees to publish anything under their own names while they were working for Guinness. So he published this test under the name Student, Mr. Student. So therefore, for a long time, it was referred to as Student's t-test. But Student was a real person and he was called William Gossett. Okay, the other thing about the t-test is the smaller the sample size, the harder it is to prove a statistical difference by using a t-test. So, as usual, larger sampling is better than smaller sampling. But remember that the t-test is generally, as I've said, used for data sets of around 30 or a bit less. Okay, so I'm going to open a sheet, and in this sheet I've pasted in two data sets, two sets of numbers. They're actually real data. I'm not going to tell you what they are because I don't want to influence the way you collect your own data. But I will say that I got the data from data search in Google, and I really suggest that the best place for you to collect data if you're doing secondary data sourcing is from this dataset search in Google, datasetsearch.research.google.com. You can type in a search term and it will return publicly available data that you can download as a zip file. It's an easy way to get a lot of data very, very quickly on the thing you're interested in. And that's where I got this data from. Okay, so I have dataset A here, and I have dataset B here. And my goal is to use a t-test in order to prove one way or the other if these two data sets are statistically different. I don't know if they are or not at the moment. Okay, so I'm going to go through this step by step. There's a lot of steps involved, and I think the useful thing about using YouTube to do this is that you can have it on your screen while you're doing your own data manipulation, and you can pause me speaking at any point as you go through each step. Okay, so I would say in order to do the t-test, there's another step you have to go through first, which is called the F test, or you need to find the F statistic. So that's what I'm going to do. Also, there's other important information you can get from each data set first of all. So let's go through those steps first. The first thing you'll probably want to know is the mean of each data set. So Excel will do that for you. All you need to do is type equals average. If you're using an English version of Excel, you open brackets and you select your data set and then press enter. So it tells me the mean of my data set A is 75.67. Another thing I might want to do is to calculate the standard deviation. The standard deviation is a measurement of the variance around the mean, and it's a nice small number that you can actually use very easily for error bars, especially if you're doing a chart or a graph for this data. So to do that, you'll type equals st dev. It gives me two options, P or S. P stands for population, S stands for sample. Well, I can tell you this is a sample of a population, so I'm going to use, let me type that again, equals st dev s, open brackets, and I'm going to select my data set again. The same data set. Press enter. There's my standard deviation for data set A. Another nice thing that Excel will do for you is it will count the number of data points you have in a data set. Well, this is a small number. I could easily count them on the screen, but in order not to make a mistake, I'm going to type equals count, open brackets, and it will count the number of data points I've got in my data set, and it tells me I've got 16 data points in data set A. Okay, the final thing I'm going to calculate is the variance, the actual variance. I've already calculated the standard deviation, but I need the actual variance value in order for my F calculation. So I'm going to type equals VAR for variance, open brackets, select my data set and press enter, and there's my value of variance. Now I need to do exactly the same thing for data set B, but Excel will do that for me. All I need to do is select my formulas, drag them across one column, and it will do exactly the same for data set B. So now I've got a comparison of means, standard deviations, variance, and counts for both data sets. Now, if you're a non-IB student, you would just look at those data sets and you would say, well, they look very different, so therefore I've proven that there's a difference between data set A and data set B. Job done. But obviously you can't. You're an IB student and you know that you need to do a statistical test in order to prove a statistical difference between the two of them. Okay. I would say at this point as well, usually in environmental systems, we'll work at a 95% confidence level, or we call it the 0.05 confidence interval. That's the usual level of certainty that we work to in our statistical tests. We don't need to go into the meaning, but when you write in your IA, when you put your statistical values, you need to quote the confidence interval, and I would ask you to work at the 0.05 confidence interval. Please state that in your results section. Okay, so we need to calculate the F statistic first of all to feed into our t-test. The F statistic, I've written here what it is. It's your larger variance divided by your smaller variance. My larger variance here is for data set B and it's 419.26. And my smaller variance was for data set A, it was 146.84. I'm sure you understand that, but all that means is I had larger variance around the mean for my values for data set B compared to data set A. So to calculate the F statistic, I'm going to do it in this box. I'll type equals, well, Excel, if I select my larger variance, Excel will put it into the box for me, divided by, slash, smaller variance. Okay, that's my F value or my F statistic, 2.86. What I need to do now is compare that against a set of already calculated values to see if my F statistic is larger than the critical value or smaller than the critical value, and I get the critical value from a data table, which I'll show you in a second. In order to decide which value from the data table I'm going to use, I need to calculate my degrees of freedom. Degrees of freedom is basically just the count, number of values in data set A, in this case -1. Well, I know the count is 16, so it's going to be 16 minus 1, which is 15. And the same for data set B. I had 15 values in my data set, 16 values in my data set, 16 minus 1 is 15. So therefore, I'm looking at 15 degrees of freedom in each case. It'll become obvious what that means in a second. So you need a data table. You can Google it. Just Google something like critical F values at the 0.05 confidence interval, and you'll find it easily. I've pasted the data table into Excel here, into another sheet. Hopefully it's visible on YouTube, and if you're doing your own t-test here, or your own f-test I should say, you can just pause the video and you should be able to find your own value, if it's visible. I'm not sure if it is. Failing that, for my class, I'll give you a table in our class so you can use it there. Okay, so I need to know my degrees of freedom for both data sets. Now what you'd normally do is you would take the larger variance, and that would represent the columns. My larger variance, I think I remember, was for dataset B, and dataset B had a degrees of freedom of 15. So I'm going down this column. And I know my degrees of freedom for dataset A, which was the smaller variance, which will represent the rows, was also 15. Oops. 15. And I'll be going across that row. Where they intersect, you can already see I've put a green box around it. The value is 2.4034. I'll copy that value and I'll paste it back into my other sheet. That's my critical F, excuse me, critical F value. Oops. I will paste it into that box below my degrees of freedom. Okay, 2.4034. Okay, I need to compare the two values I've got for the F values, my F statistic to the critical value, and I can see my F statistic is greater than my critical value. Not by much, but it's greater. So therefore, what I can say is F statistic greater than critical value. And the meaning of that will become obvious as I do the t-test now. Okay, so I know I'm going through this quite slowly, but hopefully it's made sense so far. The final step now that I need to do is calculate my T statistic. All right, I'll go through this slowly and hopefully it will make sense. To calculate my T statistic, in order to do my t-test, I type in Excel in any empty box equals t-test, open brackets. Okay, now it gives me 4 values here that I need to put in, and each one needs to be separated by a comma. Now first of all, it's highlighted array 1. That's my array, stands for data set. I select my first data set. Now this time I don't press enter, I press comma. Right, and then here it switches to array 2 or data set 2. I select data set 2. I put another comma. Okay, now it's asking me, is it a one-tailed distribution or is it a two-tailed distribution? Now what this means is you need to know if your data is, does it have direction or does it have no direction? A direction means, if it has a direction, it means you've already decided which outcome is more likely. And you haven't made that decision in this case. It's more likely that you're using 2 data sets that don't have a predicted outcome. In fact, I can't think of a case in environmental systems where you won't. So we'll call that a two-tailed distribution, and we type the number 2. That leaves us, comma, leaves us with one final decision to make, is what type of test this is. It's given me 3 options, type 1, type 2, and type 3. Okay, a type 1 test is, as you can see here, a paired test. What that would generally mean is for each set of numbers, it could be a person under one condition and the same person under the second condition each time. Now that's very, very unlikely. It's very unlikely that in environmental sampling you'll be doing a paired distribution. So therefore we're left with a type 2 test or a type 3 test to decide which one it is. Both type 2 and type 3 are paired tests. Unpaired tests. And basically what you need to decide is if the variance is similar or equal, or if the variance is very, very different. And what we've done is the F test will tell you that. The F test that we've done here, because the F statistic was greater than the critical value, that means that our variance is very different. If it was the other way around and the F statistic was less than the critical value, it means that the variation the variance in your between your samples is the same or very, very similar, and therefore it would be a type 2 test. Now, because I've done this and I know my F statistic is greater than the critical value, I know this is going to be a type 3 unequal variance test, as you can see there. So I'm going to type number 3, close my brackets. That's all the data I need for my my T statistic, and it gives me a value of my T statistic, and notice that it's in standard form or scientific notation. It tells me my T statistic is 4.097 times 10 to the power of minus 7. It's a tiny value. Now, because as I said before, we're doing our test a confidence interval of 0.05. In order for these two means to be different from each other, my T statistic needs to be less than 0.05, and it is by a long way. So therefore, I've proven that there is a statistical difference between dataset A and dataset B. If the t-stat was a large number and it was larger than 0.05, I will have failed to prove that there's a difference between the two datasets. Now, a lot of students that I've taught in the past, they've done that, and they assume that because they've failed to show a significant statistical difference between two datasets, therefore the IA has failed. Now, that's not true. It just means that you haven't proven a statistical difference, so please bear that in mind. Okay, so I've realised this has gone on far too long, but I hope I went through it slowly enough that there's enough information there for you to go through each step, pause, look at your own data set, and then carry on with the video on each case. Okay, as usual, please, any questions, please get back to me, but I think that's as much as you need to know about the student t-test. All right, take care, everybody, and I will speak to you in our class. Goodbye.